We've talked a little bit about measures of position. One of those measures that we've talked about is the quartile. And the quartile breaks a data set up into 4 groups. And the measure of center that is utilized in this method when we're examining quartiles is the median. The median is the balance point for the number of data values in a data set. So with quartiles, what we're doing is breaking it up into 4 equal groups where we have the same number of data values in each group. Percentiles, we are breaking the data set up into 100 groups. Again, the median is the measure of central tendency that we are utilizing in performing this analysis with percentiles. Another measure of position that we can talk about is called the z-score. And the z-score uses the mean as the measure of central tendency. And there is a formula for the z-score, and it looks like this. Z is calculated by subtracting the mean from a data value and dividing by its standard deviation. Now what this turns out to be then is the number of standard deviations a data value lies away from the mean. So for example, if we had a data set that had a mean of 25 and a standard deviation of 2. Let's look at that on a number line. So there's 25, 27, 29, 31, and then let's go back the other way. We're going by 2's, 23, 21, 19. So the mean is 25 and the standard deviation is 2. So if I go 2 units to the right, that's really just 1 standard deviation to the right. If I go 2 units to the left, that's 1 standard deviation to the left. So 27 would represent mu plus 1 sigma. 23 would represent mu minus 1 sigma. Now if I went another standard deviation to the right or another standard deviation to the left, I would be at 2 standard deviations away from the mean. So 29 would be mu plus 2 sigma. 21 would be mu minus 2 sigma. 31 would be 3 standard deviations away from the mean. Mu plus 3 sigma. 19 would be 3 to the left. Mu minus 3 sigma. So we're talking about, nice numbers here. And the thing is that it isn't always that we're going to have these nice numbers here where we have integers that are an integer number of standard deviations away from the mean. Let's suppose that we have a mean of 25, just like we have here, and a standard deviation of 2. And we're not looking at 27, we're looking at, let's say, 28.2. How many standard deviations away from the mean would a data value 28.2 be? Okay, so we would say z equals 28.2 minus 25 divided by 2. And that result would be 1.6. So what we would be saying then is if the mean is 25 and the standard deviation is 2, then the data value 28.2 would be 1.6 standard deviations above the mean. So now let's think about the x value 21.8. Okay, so the z value there, the z-score for the data value 21.8, we'd find by x minus mu over sigma, which would give us minus 1.6. Now, we had a positive 1.6 z-score here. This time we have a negative 1.6 z-score here, but that's not surprising because 21.8 is to the left of the mean. The mean is 25. And if I take a smaller number and subtract a larger number, I'm going to get something that's negative, and the standard deviation, of course, is always positive. So what we would say here is that the data value 21.8 is 1.6 standard deviations below the mean. So z-scores not only tell us how far away from the mean a data value is in terms of the standard deviation, it also tells us where in relation to the mean does the data value lie. If the z-score is negative, then the data value lies to the left of the mean. If the z-score is positive, then the data value lies to the right of the mean.